Hey guys, welcome to lesson 2 of unit 14. So let's get started with the warm-up. The warm-up states the graph of the function f above consists of 3 line segments. Let g be the function given by g of x equals the integral from -4 to x f of t dt. So before I even go further, I first want to identify what graph it is. It says it's graph of f. Remember, this is your derivative, right? So this would be what? Your g prime graph. F is same thing as your g prime graph. So the derivative graph is given to us. And now I want to find the values of g of -1, g prime of -1, and g double prime of -1. Find the value or state that it does not exist. So part A, g of -1. So how do I get my original graph's information from my first derivative graph? I am going to use the integral that's been given to us, right? F of t dt. So I'm going to bound it from -4 to -1. I want to find the area. So that's a trapezoid. So which is what? The area of a trapezoid is 1/2. And your height is the length across the x-axis, which is 3 times -3 base 1 plus base 2. So -5 times 3 is -15, which is -15 over 2. So that's the area. Again, quote unquote, guys, the area is never negative. Since it's under the x-axis, that is why we put the negative in there. Now, g prime of 1. Remember, this is your g prime graph. So basically, I'm going to go to 1. At 1, what's my corresponding y value? It is 2. Oh, it said g prime of -1, not 1. At -1, it is -2. At 1, it was to be +2. Okay, and now g double prime of -1. So if I want to find my g double prime information from my g prime graph, I'm going to be looking at slopes, right? So this is same thing as saying f prime of -1. So if you look at -1, there's a corner, so the derivative does not exist. So D and E, because it's a corner. Part B. For the function g defined in part A, find the x-coordinate of each point of inflection of the graph of g on the open interval for x between -4 and 3 and explain your reasoning. Okay, so by definition, when do we have a point of inflection? A point of inflection happens here if your f prime, which is given to us, changes sign, f prime, which is equal to g double prime, changes sign. I like to write it like this, so that way, you know, if you're confused between f and g graph, you're being consistent, you're not going to lose any points for that. So where is it changing sign? Meaning I'm going to be looking where it's going from a positive slope to a negative slope. So here, if you look at this is all positive. Then at 1, it is going from a positive to a negative. So at 1. So x equals 1. That's the only point where it has a point of inflection. Part C. It's saying let h be a function given by h of x from x to 3 f of t dt. Find all values of x in the closed interval between -4 and 3 for which h of x is equal to 0. So I want to find all the x values for which my area under the curve would be equal to 0. So let's look at the graph, which means what? Area equal to 0. Right? Since it's a first derivative graph, I'm going to look at the area. So what x values, I'm going to erase all this. What x values do I pick that would give me an area of 0? So look here. If I pick -1 to 3, wouldn't that give me an area of 0? Because this will cancel out with this, and this triangle will cancel out with this. So at x equals -1, so let's first set it up. Always set up your integral. So I want to, what I wrote up here, that I want my f of t dt equal to 0. So x is going to be equal to, we just saw x is equal to, oops, -1. Where else? If we have at 1 also, right? If I change, I'm going to change color so you can see it. At 1 also, these areas and this area would cancel out. Sorry about that. So at 1, and when the bounds are same, which would be 3, because that's when the area is equal to 0. So these are the three values of x for which h of x is equal to 0. So part D is asking us, for the function h defined in part C, find all the intervals on which h is decreasing. Explain your reasoning. So any function is decreasing when your first derivative, let's write this down, decreasing, is less than 0. That's for decreasing. That's the definition of decreasing, right? So I am given h of x is equal to, if I look at the bounds, it is from x to 3 f of t dt. I cannot have my variable at the bottom, so I am going to switch it. So if I switch it, what happens is I'm going to end up negating my integral from 3 to x f of t dt. Right? I want to find h prime of x. So h prime of x, I'm going to take derivative on both sides. The derivative and the integral will cancel out, and I'm left with negative f of x. So h prime of x is negative f of x, right? So if I have negative f of x is less than 0, if I divide by -1, because remember originally we are given the graph of f, so we want to try to find it in terms of f. So divide by -1. When you divide by -1, your inequality changes. So f of x is greater than 0. So where is f of x greater than 0? It is greater than 0 means when it's above the axis, so which is from 0 to 2. Okay, example, problem set 2. It's giving me a squirrel, it's saying a squirrel starts at building A at time t equals 0 and travels along a straight wire connected to building B. For t between 0 and 18, the squirrel's velocity is modeled by the piecewise linear function defined by the graph above. So we are given a velocity equation. That's what we need to identify. Then it's asking me for part A, at what time in the interval between 0 and 18, if any, does the squirrel changes direction? So by definition, anything it changes direction when velocity changes what? Sign. When v of t changes sign. So since this is a velocity graph, we are just looking from where it's going from positive to negative or negative to positive, or above the axis to below or below to above, which is at t equals 9 and 15 and t equals 15. Part B, it's saying at what time in the interval between 0 and 18 is the squirrel farthest away from the building. Farthest away means you're looking for your absolute max. How far from the building A is the squirrel at that time? So I need to find that value. So again, whenever we work with our absolute minimums and maximums, we set up a t-chart with our x and y. We put our endpoints in there, and then our critical values, and critical values by definition are when your first derivative is equal to 0. So when is it equal to 0? At 9 and 15. So these are the 4 values you're going to look for. So we know we're starting at 0, so at 0 it's going to be 0. For the others, I'm going to be finding the area, right, for f. So let's say I'm looking for from 0 to 9, I have this trapezoid, so it'll be area of the trapezoid 1/2. Your height is what? 20 times your base 1. Your base at the bottom is 5, and the other one is 9. Base 1 plus base 2. So if you simplify that, 10 times 20, which would be 9 times 5 is 14, and 140. 10 times 14 is 140. So at 9, your y value is 140. Now I want to find the area from 9 to 15. So that area would be from 9 to 15. It's below the axis. So it's going to be, again, it's a trapezoid, 1/2, and your height is what? -10 times 6. From 14 to 10 is 4, and from 15 to 9 is 6. So 6 plus 4. So 6 plus 4 is 10. 10 times 10 is 100. Divided by 2 is... So you got that to be -50, right? So 140 plus -50 would be 90. Okay, so similarly we're going to find this this area of this trapezoid. So this would be, area is 1/2, your height is 10 times 2 plus 3. It's above the axis, so it's going to be positive. 2 plus 3 is 5. 5 times 5 is 25. So I'm going to add up these areas. So this is 140 minus, we already know up till here was 90. 90 plus 25 is 150. So your absolute max is 140. That is the farthest away from the building, when the squirrel is farthest away. So the absolute max, or farthest away, from the building is 140 at x equals 9. Part C, it says find the total distance the squirrel travels during the time interval from 0 to 18. So total distance is the absolute value. We're going to ignore the negatives and we're going to add up everything from 0 to 18. So it's the absolute value of velocity dt, which is 140 plus 50 plus 25, which is 250. Part D, it says write expressions for the squirrel's acceleration, squirrel's velocity, and its distance from building A that are valid for the time interval from 7 to 10. So again, we are given the velocity function, and I want to find acceleration. Means I am going to be finding the derivative, and the synonym for derivative is slope. So I am going to be basically doing f of my velocity would be v of, not f, sorry, v of 10 minus v of 7, because this is a velocity, over 10 minus 7. I don't need to simplify it because it's asking only to set it up, give me the expression. Now I want to find my velocity. This is a velocity graph, so basically I am looking at this line segment from 7 to 10, right? So the equation of that line, would be, I need, my points are 7, 20 and 10, -10, and all I need is my slope. I can find my slope, which would be, it would be -10 minus 20, which is -30, over 10 minus 7 is 3, which is -10. The slope of this line is -10. So I'm going to write my equation. So y minus y1 equals m times t minus t1, because since it's an equation of t, so it'll be what? Y minus 20 equals -10. We already found the slope, and I picked my point to be 7, 20. You could have picked any other point, so you could have picked 10, -10 also, or any other point on that line, and it'll be t minus 7. So that's basically the equation. You don't have to solve, you don't have to do anything about it. Now and lastly, we want to find our distance, or x of t. So we are given the velocity and we want to work backwards, right? So if you want to work backwards, you're going to end up finding the integral. So x of t would be, we're starting at x of 7, right, plus, because we want to find anything after 7, the integral from 7 to t, v of t dt. So we can substitute 10 for t for anything. So I'm just going to set this up for this question, from 7 to 10, v of t dt, but you can keep substitute, like, you can find the value for anything. That integral can be used for any value, 7, 8, 9, anything, right? So anything after 7, that's basically I'm trying to say. So guys, that was it. You have one question for homework. Please do that, and if you have any questions, please don't hesitate to reach out. Good luck, guys.